Hello grade 12s, welcome to my channel and I hope you're all good. Somebody requested that I do a question from this question paper. This was the Northwest trial paper from last year, 2024. So I got this from essay exam paper. So you can get a copy there or you check the description. I will attach this question paper there. Right, let's look at the instructions quickly. Of course, guys, I almost always jump for the jugular. I don't have time to run around. Now, in all calculations, we must show formulae substitutions, right? And in terms of our numerical answers, we need a minimum of 2 decimal places for this paper. Be very careful. This is very particular to a particular paper. Don't always assume, okay? Sometimes when this instruction is not present, then you know you will follow the local instructions, okay? That's good. If not, then you do your own thing. If we're given some place to discuss or explain something, we need to be as brief as possible. All right. Okay, all right. So let's move on. So the question requested was on vertical projectile motion. So this is question 3. So this is the question. Okay, let's start. So question 3 reads, object A is projected vertically upwards from the ground. So if it is projected, what does that mean? It means it has initial velocity. And if it has initial velocity, it is itself a projectile. So we need to remember that. So always understand information given. Okay, it is projected vertically upwards from the ground. Now it takes 0.8 seconds to pass a window which is 1.5 meters high and 0.8 meters above ground. Okay, not a problem. So how do we interpret this statement? Now this time, if we're saying it passes, it means it's the time duration from the bottom of the window to the top of the window, right? Because that's passing. When objects pass each other, it's the time that it takes for them to move one across the other. So that's going to be 0.8 seconds. Okay. So please, guys, the English unfortunately has to be understood. If it's not understood, it's the problem. All right. So that's sorted. It strikes a balcony at a velocity of 4 meters per second and falls back to the ground. Now, at the same time, object B is projected vertically downwards. Again, it's a projectile at the velocity of 8 meters per second. Of course, that's downward. But now here's my problem, guys. At the same time, when? Because there's too many times here. First is the time of projection. Second is the time it passes the window. Third is the time when this hits the balcony and then starts on its way downward. So exactly when are we talking about the same time business? Now, obviously, guys, if we're going to look at the time when this hits the balcony, it hits at a very small velocity. This means it will be even smaller when it leaves the balcony. This one is at 8 meters per second. So this means definitely they will never meet above ground if this is the case. So we cannot look at the time when ball A reaches the balcony. Okay. Now, could it be the time when ball A passed through the window? Again, if there was a time lag, we would be told about it. So if it is not given, we can best assume that this is the time of projection of ball A to the time of projection of ball A is the same time at which ball B was projected downwards. This again is coupled with previous information from previous question papers of a similar sort, because by the time one writes the trial papers, they may have done this topic 3 times from term 1, term 2, and now doing it for the 3rd time in the trial paper. And in fact, one should have been doing it as many times as possible, because practicing for the trials means doing as many past exam question papers, including when one was working for term 1 exams and term 2 exams. So experience here also matters, but I feel I'm not happy with this statement because it causes a lot of trouble. Anyway, we can assume, or at least we can be comforted, that the best time to think about is that, because it doesn't seem like there's a time lag between the projection of the 2 balls. That we can settle. And then of course we need to ignore the effects of friction. And what is the significance? It means G here is 9,8 meters per second squared downward, because the force acting here is therefore the gravitational force. So we need to understand every little piece that is given so that we get used to knowing what to do when questions are a bit silly. Okay, let's start answering some questions. So 3.1, we are asked to define the term projectile. Can you see? Easy. So it's an object. It is an object that is given an initial velocity and subsequently undergoes motion influenced by the gravitational force, only. Okay, so what is important here is that the object must have an initial velocity. By the way, it has to be an object or a body with some initial velocity, and then it undergoes motion that is influenced by the gravitational force only. In my opinion, how you place the statements doesn't really matter, but what we need to know is that this is an object or a body, and there has to be some initial velocity, and we can talk about the gravitational force being the only force acting throughout its motion. There's many ways one can put this definition, although your teachers force you guys to regurgitate the exam guidelines definition because they are lazy to mark. So they want to only see what is already prepared. They don't want to think what you are thinking. They don't want to read what you are projecting. And in fact, for me, that's a fail in an examination, because the purpose of an exam is to check an understanding by the candidate of the topic being examined. So now when we're going to force people to regurgitate the exam guidelines as they are only, then it means we are just checking if this person saw the exam guidelines. But whether they understand or not, it seems we don't care. And yet we are claiming we want to produce future professionals. How ridiculous. Ridiculous as it is, I am not a teacher. So it's best to listen to your teachers than to listen to me. Now 3.2 says we need to calculate the velocity of the object A at the bottom edge of the window when moving upwards. Okay, we can say take up as positive. So again, guys, this needs to come out. So we need to say that with up is positive, we can answer 3.2.1. Now we know, guys, that the time duration of going through that height of the window of 1,5 was 0,8. So this is easy. We can say delta y is equal to initial velocity times delta t plus half g delta t squared. Now this implies delta y is 1,5 because this is in the direction upward, equals the initial velocity, which is what we want. The time is 0,8 plus 0,5 into g is downward, so it's going to be negative. And that's what we have. Therefore, what do we want? The initial velocity is going to be 1,5. Now, when we transpose this, it becomes positive 0,5 into positive 9,8 into 0,8 squared. Now, all of that is going to be divided by 0,8. But of course, for sake to simplify this first, you will appreciate that it comes out negative. Then transpose the result thereof. But I'm comfortable, so I can do it all at once. But if you're doing it all at once, be very careful of making sure you appreciate the dynamics of the signs, or else you will go wrong, even when knowing what to do. So I'm getting an answer of 5, to 2 decimal places, it's going to be 80 meters per second upwards. Remember the question said velocity. Velocity is a vector quantity, so we must have both magnitude and direction. And remember, for magnitude, we expect both the size and the correct unit. And if it is a vector, we also expect a correct direction. Now in physics, we get awarded for writing an equation properly. 2, substitutions must be correct, guys, not just substitutions. Okay, we must have correct substitutions. If any one of the substitutions is incorrect, you go down by the head. Okay, say for example acceleration is substituted as a positive answer, you lose that mark, because what did we say? We stipulated that our choice of direction is that upward is positive. So stick to your choice. But some people have a tendency to chop and change direction, which is really bad, because it makes the person who's marking you to also get lost, because they never know when you are right and wrong, because you're not clear as to what you are doing. Anyway, guys, so the answer here, magnitude and its correct unit and direction, for me is where the 4 marks come by. But another person can say the magnitude of acceleration was not necessarily directly given. So knowing that it's going to be 9,8 in magnitude, that could also be where the 4th mark is, and saying the last mark is for both magnitude with a correct unit of measurement as well as the correct direction. So it doesn't really matter. You can download the, the marking guidelines, so that you can see how this question was marked, provided you see an answer that comes out in the same manner, or at least calculated in the same similar manner. But as long as you understand, it's all good. So 3.2.2, we need to determine the velocity of object A with which it was projected from the ground. Okay, not a problem. So remember, we just found the velocity at this level. So the velocity here becomes now the final velocity. This is 5,80 meters per second. Now between the ground and this, we have been doing a displacement of 8 meters, and we want the initial velocity from the beginning. So that's where we are looking. So we can see that we can say the final velocity squared equals the initial velocity squared plus 2g delta y. Always, guys, choose an equation that will only give you one unknown, and the unknown must be the one in question. So the final velocity here we just calculated, now it's 5,80. We are squaring it. Initial velocity is what we want. 2, this one is going upward, acceleration is negative, and the delta y is in the upward direction as well, so we write it as positive. So therefore the final velocity, the initial velocity is going to be the square root of, now we take the final, remember this would have been negative, so it goes on as positive. Again, you can simplify that before you transpose to avoid unnecessary problems, but I think simplification should be something you are familiar with. This is why doing physics without doing maths is suicide, guys, because if you don't know maths, simplification is maths, isn't it? Now if you don't know maths, it means you are bluffing. So 13,80 meters per second, again upwards, because this is positive, so it comes out following our choice of direction for the entire question. But some people are silly, they can choose direction for each individual sub question, which is as dangerous. It's a very dangerous plan, but you can do it if you can survive it. So writing the correct formula and doing correct substitutions. Remember, if any one of these substitutions are incorrect, the entire thing is wrong, provided you gave that choice. But if you didn't choose a direction, then you can get your marker confused, because when you get the answer incorrectly, they don't know exactly what you were thinking and what you are doing. And then of course the final mark here is for both magnitude, correct unit, and direction, because the question was on the velocity. So please, guys, treat vectors with a whole lot of respect. Not respecting these is committing suicide. Okay, we're doing well. We are winning. So now we know this is 13,80 meters per second. So we have sorted this. In fact, guys, I would propose, if it is not the case, because I doubt this is given in the answer books or answer sheets for physics, but you can see that annotating the diagram also helps for the marker to follow the pattern of thought by the student. But of course, you are allowed to do your own sketch to highlight what you're doing, but I think it's much better when we do the annotations on the sketch provided, so that we don't lose the meaning on the sketch. I would propose that in this upcoming exams, and in fact exams going forward, we should provide a page or some sheet or some pages that have the sketches according to the question paper for a particular question, so that if the student wants to annotate that sketch, then they can do so, so that at least it's easier to follow what the student was doing, rather than to try and imagine what on earth were they thinking. I think that is very important. In fact, I discourage the issue of putting the diagram in some dedicated lines in which to answer a question, because for me, some students want to write more, others write less, but we shouldn't really segregate those students, or at least punish those that want to write more, so that to them it makes sense what they're doing. Because remember, what the student writes is what makes sense to them. And it should be about them, not about the lazy person who wants to mark fast and finish. No. If you want to mark, you must have the patience. If you want to teach, you must have the patience. Okay? Let's not cut the corners, guys. Our future is at stake here. These guys are the future. Remember, what we cannot achieve, they can achieve. So we must allow them the chance to do so, rather than to restrain, or should we say to restrict them to what we know and what we couldn't use any further than, what we can show them, because we ourselves are the victims of those who taught us in a very restricted way. We can't do that, We can't. This is why we made these channels, guys, so that we can share what we knew, which brought us to this level that we are at the moment, so that you guys have it easy to even jump higher than we could. Because the moment you don't have to struggle with the little things that we had to struggle with, then it means you can even discover more than we could discover. Okay? We can't force you guys to struggle the same way we did, because that means you're not going to move any higher than we could, especially if you're not as gifted as we are or we were. Then it means the future is hanging in the balance, isn't it? But if we give you what we know we have discovered along the way and mastered, then it means you will master what we know and even master what we don't know, because your brain is going to have enough liberty to think even higher and beyond. And that means our future is in great hands, because it means what we need in the future, you will be able to measure up to that level. But hey guys, what if? A lot of people are lazy and they just promote laziness as a result. And then they claim everything is wrong after that. And they don't realize that they are the very problem in our education system. Anyway, guys, let's leave the politics for the politicians. And besides, I am not a teacher. I will never be a teacher. So what I have to say doesn't mean anything, because I don't know what people who become teachers go through in teachers training and what they're told, what are the principles and what. I'm just a fanatic of the two subjects, because I mastered the subjects when I was a student, and what makes me even more enthusiastic about them is that I had to do all the groundwork by myself mostly. But my teachers did give me some very good support when they could. But I was one of those ambitious young freaks. I just jumped for higher grade for every single subject, all my 6 subjects. I took them at higher grade level for the first time in metric. And my teachers, I kind of gave them a steep hill, because they were used to teaching standard grade, everybody, especially maths and physics. I doubt if anyone in my school did higher grade before me. Okay, maybe it's what we call grandiose delusions. Maybe I'm delusional to think that, but I don't remember anyone doing maths at higher grade in my school before me. At least the 2 classes before me did not. I was the first one to do so, and I passed it with distinction. Maths and physics, I killed them. So this is why now ndiniqhegezela nje, maqhekeza nje naninihlafuni. Mhlawumbe nizawukhula longer than me and faster than me and nibe ngcono kunami eventually. But if not, then too bad for you guys. Okay. So yeah, man. Let's go on. Let's not talk about stories. I think this one is going to be a long one. So let's just give it a new page. I can smell trouble for this one. 3.2.2. What is the question? We are to calculate the height above ground at which ball A and B will pass each other. And as we could say safely, guys, that look, again, this question itself, as much as the statement was a bit vague, but I think if we are to consider these two meeting above ground, we have to exclude the fact that this is the case, right? Because it cannot be from the time this hit the balcony and this one was being released, because then they will never meet above ground. And at the same time, we were not really clearly told the time lag between the two, so we cannot consider the time at which this was passing through the height of the window. It has to be, honestly, the time from which ball A was projected from the ground. That ball B was also projected downward. Okay, so can you see, if you understand the question in its true sense of meaning, you will be able to even follow some clues on the question, because of course, I mean, the person who submitted this is also human, right? He may have thought that at the same time ball A was projected, object B was projected. Maybe they wanted to say that. But sometimes I realize I have a tendency to complete my statements in my head. And in my writing, I just stop somewhere before I could finish the sentence. And in my mind, I thought I finished. And then you submit. But again, I wouldn't blame the person who actually wrote the question. But I blame the quality assurer and the moderator, because their job is to ensure that every question makes sense. Any student should understand the question, perhaps fail to answer because of poor knowledge and poor prepared. Sorry. Yo, something got into my nose. I don't know what it is. Maybe I'm swallowing a... Yo, hey, this is very scary to even think, guys. Maybe I'm swallowing... What are these things that fly around? A mosquito. Maybe it went into my nose because something got into my nose for sure. And I swallowed it. I'm gonna be fat now because of it. But anyway, because I grew up skinny and I'm not really that nice and, you know, chubby. And I wanna be chubby, guys. Anyway, enough nonsense, guys. Let's get to the question. So again, guys, sometimes if you're having struggle to make up your mind about some statements, sometimes skim through the questions and see if you can find a clue that can give you an understanding of what is going on. As you could see, we anticipated that these will have to pass each other at some point. And so we knew we could eliminate two possibilities, provided it wasn't explicit that there was a time lag between the release of the two. And so we could sit with the fact that perhaps, and now this question already makes it even more probable that what we chose is correct. Okay, guys, so now let's plan. What is the plan to answering this question? Let's say these dudes meet here at this point, okay? Now, this would be the height above ground in which these two meet. Let's call it H. Okay? And let's say the time, because they must have traveled the same time, must be t seconds. Okay? We don't know the time, but that should be the time these two meet, because they can only meet if they've traveled the same time. There was no time lag between the two. So we'll not think about it for now. Now, this could be easily looked at ball A going up this distance or this displacement for this time duration. That could be easy. Or we look at ball B going down this time, this vertical height, we can call it delta Y, and for this very same time duration. But for ball B, it's going to be a bit complicated because we need to consider the height of the balcony above ground for that. So we can call this one H. Maybe let's call this one H1. Therefore, this becomes H2. But the question is on H2. H1 is just a means to an end. So again, guys, I see planning and annotating the sketch helps a lot, because we know now that this vector, we should consider this as a vector now, because that delta Y is a vector itself. So we know that this is down, this is up. So essentially, this is going to be the summation of the two vectors to get H2 for ball B. So ball B provides a bit of a complicated situation. But again, with the sketch, with the right annotations, with understanding of what we need, then we can proceed, because now we can answer the question of H2, because this is the ultimate question. And that means if we're using ball B, we need to consider the summation of vector H1 and that delta Y for ball B. Or we just simply take ball A from the bottom until H2. So it's just going to be H2 for ball A. So this is very important, guys. This is why, again, these sketches are very important to provide for students to annotate so that we can understand their thinking. Now let's say let the balls, okay, maybe let's say let the height balcony be H1 above the ground, and say, and, okay, and, now I see the end is not written, and meet at H2 above ground. Okay, now what meets? Okay, and what is going on now? And the two balls A and B meet at height H2 at time t seconds. Alright, so guys, always try to set up this thing. So we're going to say let the height of the balcony be H1 above the ground, and the two balls A and B meet at height H2 above ground at time t seconds. So again, these are very important things to make sure. When we talk about t, the marker understands what we're talking about. When we talk about H1, they need to understand. So it helps to put a statement as well as an annotation so that nobody starts to get lost, especially if your answers end up being incorrect. Someone would understand exactly where you deserve marks, okay? But if you don't set this up nicely, you end up losing the entire 6 marks, because if everything is easy, it's difficult to follow, it's easy for someone to just say, okay, the student is not careless, is not careful, so this one must just go down, because what's there to think about? So don't make those people angry, make them excited that you are very organized. Anyway, let's start. We can say for ball A, we'll say delta y A is going to be equal to V I delta t plus half g delta t squared. Now this implies, now remember, this is the height ball A is when they meet. And what is that height is H2. So this implies that H2 is equal to, what was the initial velocity? 13,80 times t, which is the time at which these two meet. Can you see? We are setting this up nicely. 0,5 into, remember ball A is going against gravity, or it doesn't really matter. The gravitational acceleration is always downwards, okay? Into t squared, okay? So what can we say? We can say therefore H2 is 13,80 t plus, maybe let's put it in brackets to show it's a substitution back there. So the sign here, this is going to be negative, so it's going to be 4,9 t squared. Okay, we can make this equation 1. Obviously, the concept of simultaneous equations applies here. This is again another issue that says if you don't know maths, it's very difficult to do physics, because physics is nothing but maths applied. Of course, in different ideas of some true sense of nature, but we can model maths into that so that we can understand the patterns and the dynamics. Otherwise, we would not understand what's going on. So also, what do we know? We can look for ball B. We can say, well, delta y for B, now I'm talking about y above ground, is going to be equal to, now remember, we need to think about these as vectors, not just a mere height. Now this one is upward, so it's going to be h1 plus that delta y, which is downward. Sorry. And the delta y here is going to be the initial velocity delta t plus a half g delta t squared. Okay. So this implies now this delta yb, we are talking about that same height above ground, or the height at which they meet. So this is h2. It's going to be h1 plus, so this one was downward, so it's going to be 8 into t plus 0.5. Again, the acceleration is downwards, into t squared. So therefore h2 is going to be h1, this becomes minus 8t, again that becomes minus 4.9 t squared. Okay, so this is very great. So we can make this equation 2, but maybe because we still have an unknown h1, we need to justify how to deal with it. So we can say, but we know that the final velocity squared equals initial velocity squared plus 2g delta y. This is for ball A because we know the initial velocity now. We know its final velocity when it hit the top of the balcony. So we can find h1. So this implies 1,4 squared is equal to, what was the initial velocity? It's 13,80 squared plus 2 into minus 9,8 delta y. In fact, instead of writing delta y this time, we can write h1 because that's the height of the balcony above ground. So we can say, therefore, our h1 is going to be 1,4 all squared minus 13,80 all squared divided by 2 into minus 9,8. Now let's do it quickly. So we have here 1,4 all squared minus into 13,80 all squared divided by 2 into minus 9,8. So I'm getting a 9,616 meters. Remember, this is an intermediate answer, so we must protect the answer a bit. So what can we conclude? We can say, therefore, we see that h2 in terms of ball B is going to be equal to 9,616 minus 8t minus 4,9 t squared. Now we can make this one equation 2. But now what do we notice? h2 is equal to h2. So it's the same height. So what can we say? Then we understand that essentially so we understand that 13,80t minus 4,9t squared must be equal to 9,616 minus 8t minus 4,9t squared. Of course, this is because equation 1 is equal to equation 2. You can justify it, you can leave it out. Somebody understands that those were both defining that H2. So we just simplify. Now we can see that maths comes in, mathematical gymnastics. This and that will cancel out because they're of the same sign on either side of the equal sign. So when you transpose one side to the other, they actually cancel out to 0. Now all we have left is to take 8t to that side and leave the number on the one side. So this implies now 13 plus 8 is what? It's 21,8. So we'll have 21,80t is equal to 9,616. You can say therefore the time t is going to be 9,616 divided by 21,80. So 9,616 divided by 21,80. Oops. So this gives us an answer of 0,441 to 3 decimal places. But remember, 1 is totally insignificant. There's not even a need to keep it, but let's leave it. It's an intermediate answer. This is seconds. I never feel comfortable writing seconds as just S here, because my S looks like a 5, so I always put it in brackets. I don't know why. Maybe it's accepted, maybe it's not. So guys, once we know the time, we can then use any of the two equations to find the height. So we can say therefore H2 is going to be 13,80 into 0,441 minus 4,9 into 0,441 squared. I'm using equation 1. So this is 13,80 into 0,441 minus 4,9 into 0,441 all squared. So I'm getting an answer of 5,13 meters. We can say therefore the poles A and B will pass each other at 5,3 meters above ground. Okay, so I always make a habit of answering the question at the end, but this is, you can see guys, this is like an essay. It's one of those questions that chow time, and they're very technical in nature. So a very clear game plan here is your absolution. If not, you die a slow death with a very wide smile of shame. Anyway, so please guys do check the memo here, because yeah, this whole thing is a mess. Just check on the memo if I did not mislead anybody. So folks, I would go for this mark because we've been using this equation all along, so I don't think it's that important, but we'll decide later on. We also used this equation, so I would perhaps say technically this is important, and so this becomes important. 3 marks. Now equating the two usually is the 4th mark. Finding the time is the 5th mark, and finding the distance, answering the question, is essentially the 6 marks, because obviously the same question, we need to check if we used different equations. If we're using the same equations, we then can ignore that. If we're substituting, sometimes we get a mark, sometimes we don't, depending on the intensity of marks in this question. Of course, this could be given more marks because there's so many things going on. But now, it's only just 6 marks. Okay, let's do the last question, guys, before I take too long. 3.3 says, draw a position time graph. So this is a displacement time graph, not to scale, okay? For the entire motion of object A, and B on the same set of axes. Now the entire motion, guys, it's all of them. Ball A up and then back to the ground, and ball B back to the ground, because the end is the ground. Okay, from the moment they are projected, it says label the graphs and clearly indicate the following. The height the objects pass each other, okay, and the time the objects pass each other. Can you see we worked it out as well? So we saw that this essentially came out as 0.441 seconds. And we calculated this height to be 5.13 meters. Easy stuff. So now we can sort it out. We know that, well, we need to write a position time graphs of balls A and B. There has to be a topic. Don't just draw a graph. We don't know what graph it is. And then, of course, the ground is the reference point in this case. So we're going to have here time in seconds. Then here we have position in meters. And then, of course, this is ground zero. So for ball A, we know, guys, it's going to be like this. It's a parabola, right? It's a parabola. They may be equal, they may not be equal, but I think we should try for a parabola. Yeah, that almost the two sides. Well, the time up, the time down is the same, so it should be a bit symmetrical. And okay, I wanted it to hit that line. So remember, this is the total height. Okay, and then here comes the graph for the other one. The other one just goes down like that from the same total height. So what are we supposed to indicate? The height where the objects pass each other. So this is the one right here. So we can break this up. So we saw that this is 5.13, and obviously the time when they pass each other is also this one. So this is 0.44 seconds effectively. Okay, because this was an intermediate answer, but I mean, when it is the final answer, we can round off to 2 decimal places. It's safe. So we just need to label that this is for ball B, this is for ball A. So I think we are done here. So this is it, folks. Very nice question, but some blunders by the examiners, or let's not blame the examiners, but rather those people. So of course, guys, how many marks? 4. So the shape for B, the shape for A, we know these are parabolic and essentially indicating the time, the height and the time. That's the 4 marks. And now this is for a total of 19. Okay, the last 6 marks or even 10 marks can give students a bit of an issue. But again, if guys have been practicing and you've been attending classes and you have been watching these videos for meaning and for understanding, not just for entertainment, there's no way you could come out less than 80% for this question. So always aim to score 80% of each question, at least, meaning you can score 80 or more. If it goes to a push and shove, try to aim for the 80 at least. Try to get it by being strategic. I've shown you guys how marks are distributed and what motivates giving a mark. So if you cover those bases nicely, even if there's a mistake along the way. Make sure though that you score marks enough to still maintain an 80% of each and every question in totality. Then you can keep your distinction, which is the plan. Plan is to keep those distinctions from term 1 until the last term so that you can get to the university of your choice and you get to do the career that you want. But be very careful. Be very careful. Choose wisely what you want to do. But don't give up just because it's hard and difficult and challenging. So leave a thumbs up, guys, and please practice. I will attach this question paper. Practice it. I see a pendulum here. I've done a lot of questions on a pendulum, and you can see here work energy theorem again on a slope, electrostatics, current, electricity. It's my favorite, by the way, this one. It's one of those questions that used to be a nightmare. But I found a way of dealing with them, so I knew I was getting marks here no matter how challenging they make it. In fact, I almost always enjoyed the challenge because I knew I was gonna be up to it. Well, these ones we did them in grade 10, but not to the extent that you guys go at anyway. This photoelectric effect, perhaps we did the basics of the wave nature of light in grade 10 rather than this. And then of course we did refraction and what, but it was not exactly the way that you guys do the photoelectric effect. But in essence, it's nothing but the same thing, because in physics at university we did radioactivity. In a way, this is the topic, by the way. Of course, with a bit more detail and more challenges. But yeah, guys, I've done full papers before. I will still do full papers for you in future, but not as many as you probably wish. But use the papers I have done to outmaneuver these papers so that you can do this for yourself and to master your subjects. And guys, there's no excuse. If you don't practice, you don't study, you don't read, you don't follow instruction, you don't take guidance, because I would call what I'm giving you now, guys, as guidance. Don't fixate on this particular question I've done with you, but look at the method, the techniques, what motivates my actions, and from what piece of knowledge am I drawing all my actions and conclusions. And eventually, you will then be comfortable with this so well that whenever you're looking towards an exam, you actually look at it without anxiety, but with eagerness, because I can't wait to get a challenge on VPM. But whatever that challenge is, I'm going to be up to it, because I'll make sure I have enough time to answer that question. You look at those sections that are challenging, but if you look at them with enthusiasm, I promise you guys, even if it gets too hard, sometimes you won't have to answer all the questions, even in that topic. Some questions are very ridiculous. They are very difficult. Sometimes way too difficult. But remember, an attempt is better than just crying about it, okay? Anyway, guys, good luck with your physics. And yeah, this topic is one of those topics you need to watch out. So please practice every single question on VPM that you can find, whether for term 1, term 2, term 3, term 4, be it a supplementary paper, be it a final paper, whatever it is. Do as many as you can. Of course, build up from very easy and basic questions on your textbooks, on your study guides, then take it up to some basic tests in term 1, and then you take it to some technical tests of term 2 and term 3, and essentially the ultimate, which is term 4, and the May-June supplementary exams. You should be fine. You should get full marks. If not, you should always score 90% of every question, minimum 80% of every question, so that you get to keep a distinction, and so that it's not so difficult for you to get a distinction at the end of the year. Although this distinction, guys, I have a problem with it. Okay, let me be mean. The distinctions you guys celebrate are not true distinctions, man. Not at all, not at all. These are just controversial distinctions. Why am I saying this? It's because the level of the exam is not one you could say someone who passes it well has scored a distinction. Maybe we can say merit. What you guys call a distinction, I would call it a merit. Back in the days, it's a merit, guys. It's a B, man. It's a B. It's not an A. For you to score an A, you must survive higher grade questions. Higher grade material from the beginning to the end. You can't be doing standard grade material and then you say this is a distinction. No. A distinction, the word says it itself that, this is a distinguished candidate. It's a distinguished, what? Yeah, it's a distinct candidate. I wanted to say that. But now I see the words just pile up on my tongue and I end up talking nonsense myself. So anyway, guys, whatever I'm saying, it's ridiculous. Maybe I'm mean because we had to endure pain and you guys are not really enjoying pain to get a distinction. Maybe I'm mean. Maybe I'm jealous. Otherwise, I'll see you next time. Goodbye.